Hi, this is Leah, and this is week 7 of our interactive advanced concept presentation. And this week's topic is balloon geometry. So some key concepts that we need to understand for this week are molecular geometry, which is the three-dimensional shape that a molecule occupies in space. And in this advanced concept presentation, we're going to use balloons to represent these different shapes. We also need to understand electron domain, which is the number of lone pairs or bond locations around an atom. So the total number of electron domains will affect the shape that the molecule takes, and also the number of lone pairs that are present. So we have an example over here. So if we would look at this molecule, we would see that there's 1, 2, 3, 4, 5 different electron domains connected to this main central atom here. So let's go ahead and dive into the different types of electron domain geometry. So the first type is trigonal planar. So we know that a trigonal planar shape has to have a total of 3 electron domains. So we have 1, 2, 3. It has one pair of lone electrons. This is right here represented by the 2 dots. The type of molecule is AB2. And then an example of a trigonal planar molecule is sulfur dioxide. So in this image, the central atom would be where the balloon knots are. So for the example of sulfur dioxide, we would have sulfur in the middle here, 2 oxygen molecules as the purple balloons, and then a pair of lone pair electrons up here represented by the pink balloon. Our next shape is tetrahedral. So the total number of electron domains here is 4. So we have the pink one and then 3 purple down here. The central atom would again be where the balloon ties meet in the middle. We have 1 lone pair of electrons, which is represented by these 2 dots. It's an AB3 molecule. An example of this would be ammonia. So nitrogen would be in the middle where all the balloon ties together. And then we have 3 hydrogen as the purple, and then 1 pair of lone electron pairs up top here in the pink. Our next shape is tetrahedral. So we have a total of 4 electron domains, 1, 2, 3, and 4. We have 2 lone pairs, so this pink balloon here and this second pink balloon. The type of molecule is AB2, and this subscript here just means the number of bonded locations. So these 2 purple balloons, for example, would represent the B subscript 2. An example of a tetrahedral shape with 2 lone pairs is H2O, so it's water. We would have oxygen in the middle here, 2 hydrogen atoms here, and then 2 lone pairs of electrons up top here. Our next shape is trigonal bipyramidal. We have a total of 5 electron domains, so 1, 2, 3, 4, 5. We have 1 lone pair of electrons, represented by the 2 dots here on this balloon. It's an AB4 molecule, so there's 4 bonded locations, 1, 2, 3, and 4. An example of this would be sulfur tetrafluoride. So similar idea as the previous ones, sulfur would be in the middle where all the balloon knots connect. 4 fluoride atoms connected, and then 1 single lone pair of electrons. We have another trigonal bipyramidal shape. The difference with this one, just as how we saw with the tetrahedral, was the number of lone pairs. So this is how I was saying before, the number of lone pairs will also affect the shape. So it's still trigonal bipyramidal because we have 5 electron domains, 1, 2, 3, 4, 5. So that 5 comes from the number of bonded locations as well as the number of lone pairs, which we have 2 lone pairs, both of these pink balloons. It's an AB3 molecule, so there's 3 bonded locations. And an example of this shape would be chlorine trifluoride. So chlorine would be in the middle where all the knots connect. We would have 3 fluoride atoms and then 2 lone pairs. Another trigonal bipyramidal, which is different because of the number of lone pairs again, just as we saw in the last example, but it still has a total of 5 electron domains. So we have 3 lone pairs here represented by pink, and then 2 bonded locations represented by the purple. Since we have 2 bonded locations, the type of molecule is AB2. An example of a trigonal bipyramidal electron domain geometry with 3 lone pairs would be chlorine difluoride. Oh, I'm sorry, that's supposed to be iodine difluoride. So we would have iodine in the middle, 2 fluorines here, and then 3 lone pairs of electrons. Our next one is octahedral. So we have 6 electron domains. So we have our central atom where all of the balloon knots connect. Then we have 1, 2, 3, 4, 5, 6 electron domains. One of them has a lone pair of electrons. Since there's 5 bonded locations, it's an AB5 type of molecule. And an example of this would be bromine pentafluoride. So bromine would be in the middle here, 5 fluorines around it, and then 1 lone pair of electrons. And then our next one, which is also octahedral, but it differs because of the number of lone pairs. Since it's octahedral, we still have 6 electron domains here, 5, 6. 2 of these are lone pairs. Since there's 4 bonded locations, represented by the purple and the green here, it's an AB4 molecule, and an example would be xenon tetrafluoride. So we would have xenon in the middle, 4 fluorides around it, and 2 lone pairs of electrons. And that are all the different types of electron domain geography shapes. Thank you for listening.